Rating your.
Miss Lane, he's writing your review. No, look at his notebook. No, look at his notebook.
I'm being observed.
No, come on.
This is out.
Is this recording it? Did I record this?
Yes.
Well, both the dances you
In
can
the
see.
middle of my math class.
I give you 1 star.
You know I can like type grades into your grade book, right?
Oh.
And
Well,
messages to your parents,
cross that out.
right?
What was the?
You better give me a better review.
Give her 10 stars, bud. Never mind. Never mind.
10 million stars.
Now, we are going over numbers 35 and 37 from the homework. I'm actually going to do number 37 first because it's actually a little bit easier, and then we'll go into 35 because it's credit. Okay? Then after I go over these two, we're going to go into the lesson today about division with powers. And then it'll be like almost the weekend, which is great. Okay, stop talking. Yeah, he's excited because he's spent the whole weekend in the bathroom. Okay. So, okay.
Did that hurt?
What'd you do? Oh. Okay. Scientific notation. When do we use scientific notation?
Science.
In science, and apparently also in math, right? Because math and science kind of like are BFF.
No.
So we're not talking. It's my turn. I'm the star of this show right now, okay? All right. So we're using scientific notation to represent the value of numbers. Can anybody tell me why we might use scientific notation? What about these numbers might require us to use scientific notation?
Because I have exponents.
No, like what about the numbers themselves? Yeah. Because why? Some of them are, yeah. And that's pretty much the answer I'm looking for, yeah.
They're too big or too small.
Yeah,
to
very
write
good.
out.
All of those answers are pretty much, yes, the right answer. So I couldn't
Yes.
think of the term. All those answers are great. Sometimes numbers are like super, super big, like the number, I don't know, 0.000000000000032. Nobody wants to write all those zeros. If you just look at those zeros, you can't tell me how many zeros there are unless you count them individually. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. What are you, some sort of counting genius? All right. Well, what about this? No. Okay. But it's really like a lot to handle. So there's a neater way to represent that value. We would have to make sure that the decimal in the scientific notation would be in a spot to give a ones place, and then the rest would be decimals. So that would be right there, right? You have to have, in scientific notation, you have to have a ones place, and then the rest can be decimals. Sometimes there aren't any decimal numbers after that. Sometimes if it's a whole number, like the whole number 4, that's fine in scientific notation. But here, the number wouldn't actually be 3.2. You would have to represent where the decimal actually belongs with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, because it's all the zeros and this guy. So it'd be to the negative 14. Yeah. So you guys are pretty familiar with scientific notation and why it's written that way, right? Much more organized way, and we can compare numbers and do operations on numbers. Calculators are just for math, not for fun, okay? Even though they are tons of fun. So scientific notation has its place. It kind of keeps things organized and condensed so we don't have to deal with all that.
Like
Not
this.
because in science you're dealing with like cells or like miles to the sun or something like that. And like the numbers get big or the numbers get really small.
Just like
Scientific notation helps. Please only if it's like super important for learning, okay? All right, so Going back to number 37, we're gonna do first because it's a little bit easier. 2 times 10 to the negative third to the third power. First, we're gonna use our rule. His hands down, please. First, we're gonna use our rule for when something in parentheses is being raised to a power. What does that mean for what's inside the parentheses?
They're being raised.
The power outside is distributing to all the powers inside.
Yes, the power outside belongs to everything. Jocelyn, are you paying attention? Kind of? Okay. The power belongs to everything in those parentheses, okay? So that's 2 cubed. 2 cubed times 10 to the what?
11. First power.
Negative 9.
Negative 9.
Yeah.
Because we have to use our rule for raising a power to a power. We multiply our exponents. Negative 3 times 3 is negative 9. Now, we can just simplify this to be what? 4. 2 squared is, oh, I'm sorry, I wrote the wrong thing. Yeah, it's 8. 2 cubed is 8, and then times 10 to the negative 9. 2 questions for you. Is it okay that I have a negative exponent?
Yes.
Yes. Scientific notation is the exception to that bad attitude rule. Negative exponents are okay in scientific notation because it's just representing the place value where the decimal should actually be, okay? So negative exponents are fine. You don't have to simplify that. My next question, is this number 8,
Yes.
is that okay in
Yes.
scientific notation?
Yes.
Yeah, whole numbers are okay, because it has a ones place and nothing else beyond the ones place. Yes,
But also scientific notation, can you have like an 8.1 or something like that?
absolutely, but we don't have that here, so we don't represent that. Okay, so this is actually done. This one was pretty easy. This one,
35.
35, looks super innocent, but it's not. Okay, so what we have here is the 4 being raised to the 5th power.
Which is, no, never mind, I was about to
That's
do
gonna
4 times
require a calculator times 10 squared to the 5th
1024.
power.
1024.
1024.
Wait,
What's wrong?
why was the power not distributed? Oh,
It is. So it's really hard to talk over all that. 4 is being raised to the 5th power, which if you punch that into a calculator, I wouldn't expect anybody to actually multiply that out. You just put 4 to the 5th power in the calculator and you get 1024. And then 10 squared to the 5th power is
Oh, that's 10 or 10 to the 10th.
10 to the 10th.
That one you multiply, not
Times
the other one.
10 to the 10th. Also, somebody mentioned earlier, they said, didn't you say you're not supposed to use x to show multiplication anymore because it gets confused with variables?
Well,
Again, scientific notation is the exception to that rule.
There's a lot of exceptions.
Could you just, there's a lot coming, and it's like helpful, but it's also taken up a lot of time. So I will just if I have a question, you can raise your hand and answer it, okay? So we have 1024 times 10 to the 10th power. Yay, I'm done.
No, you're not.
Excuse me?
Have the
Yes,
decimal
solve it.
point by the 1.
Right, so this, yeah, I'm smelling what you're stepping in. Okay,
What?
What?
I'm smelling what you're stuffing.
Four.
It's like it's. I'm receptive.
like,
Be quiet, Bo.
I'm so sorry, sir. I mean, ma'am.
Can I continue?
yeah.
1024 is not an acceptable scientific notation number. So the decimal is here. Where should it be?
Right after the 1.
Right there.
Here. So I'm going to rewrite this as 1.024. But I can't just go rewriting numbers because that changes the value. Yeah.
10 to the 13th power, since you move 3 digits to
Yeah.
the left.
The way that I do it is, and this is just me. The way that I do it is I rewrite it first, then I look at it and say, okay, how many do I have to move it to go to what it really was? That would be 1, 2, 3 to the right. And then I add that to my power. So it'd be 10 plus 3 is the 13th power. So it'd be 1.024 times 10 to the 13th power. And that's it. And that's it for the homework. And now we need to go into our lesson. Woo! Ready? So your notebook is open. The date is at the top of your paper.
What?
Well,
And this is what you're gonna write at the top. Bo, I just said, and this is what you're gonna write at the top. And you don't have the date on there yet. I said, open your notebook and write the date. And then I said, and then this is what you write at the top. Oh, it's right here. You're welcome. I almost tripped on it before. I almost did trippies. Yeah. It is hot in here. Am I recording? Yeah. Okay, good. Can you take off the sweatshirt? Oh, is she okay?
I mean, I'm gonna have to.
Yeah.
I'm melting.
Yeah, my hair's like hurting.
Okay. I have like 10 minutes. Can you just give me 10 minutes? Yeah. I'm waiting for it to be silent so I can begin. Okay. Still waiting. Okay. So today we're doing division properties with exponents, and the good news is it's basically the opposite of what we learned about multiplication, which makes sense because division is the opposite of multiplication. What's up?
I remember this lesson.
Good.
Can I?
It just takes so much extra time. Okay. So the division rule is the opposite of the multiplication rule. Just like division is the opposite of multiplication, so it's easy to remember. But before we go over the rule, let's review what the multiplication rule was. I'm going to use these same numbers, but I'm going to show it in a multiplication problem. No, I'm not.
Oh.
Terrible. Right? It's a really awkward. It's a really awkward situation. Okay. 4 to the 5th times 4 to the 3rd. I'm using the same numbers, but it's a totally different problem. Please remind me of what I do with my exponents. So it's 4 to the 5 plus 3, which is 48. Because this is 4 times 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 4. That's 48 total, right?
Yeah.
So when you're multiplying your bases and they're the same, you add your exponents. What do you think is going to happen when you're dividing your bases that are the same?
Oh my God.
No, I mean.
Listen to it again. I want everybody to think of this. If you're multiplying your bases, the rule is add your exponents. You got it now? What is it? Yes. So if you're dividing the same bases, we're simply going to subtract. 5 minus 3 is 2, so it's 4 to the second. And if you look at it written out, 4 to the 5th, like I said, is 4 times 4 times 4 times 4 times 4. 4 to the 3rd is 4 times 4 times 4. And if you show that in division, 4 over 4, if you have a 4 over 4, that cancels itself out, right? So that's gone, that pair is gone, and that pair is gone. And by gone, I mean it does turn into a 1. Stop. It does turn into a 1, so it does exist, but it doesn't need to be shown unless it's the only thing that exists. Then you can make it show up. What we have left is 4 times 4, which we represent as 4 squared. But of course, we can skip all the craziness and simply just do 4 to the 5th minus the 3rd. 4 to the 5 minus 3 is 4 to the 2nd power. Pretty easy, right? This concept we will use throughout this lesson. But of course, they're going to get uglier and uglier as we go along. They need a makeover. We need to simplify them. It's like, have you ever seen somebody who's wearing like too much makeup, too much jewelry, and you're just gonna be like, let's
Too
take
much
off
perfume.
this piece.
Yeah.
Oh yeah, that's not good.
No.
It's like, usually it's like the older ladies, and you're like, the hair and the thing, and the earrings and the necklaces and the makeup and the, yeah. But anyway, back to numbers.
But then it's like an old tiny style too. It looks even worse.
All right, so let's look at an example that changes it up a little bit. Same process, but it's gonna cause something a little bit different. We're gonna do the same thing. If the base is the same, what do we do with our exponents? Subtract them. Somebody asked in an earlier class a really good question. They said, do you subtract the bigger number, the bigger exponent minus the smaller exponent, or do you subtract the numerator exponent minus the denominator exponent? What do you think the answer
The
is?
top one goes first.
Yeah. The numerator exponent is always the first number. Then you subtract the denominator exponent, even if it means getting a negative exponent in your answer. And if you're like me, you're gonna get that and you're gonna think you're done. Because for some reason, I always think I'm done. And then I remember, wait a second, negative attitude needs to be taught a lesson. Go down to the
Put it in the
dungeon.
basement.
Go down to
Go
the
to the
dungeon.
torture chamber.
Shh.
I'm so sorry.
Go to the dungeon and get a positive attitude. So we end up with 1 over x to the 3rd. Over here, total same rules apply, but now we have, of course, our rational exponents. So you use the rule that we just learned along with your rules for subtracting fractions and getting common denominators, and you're good. Same base, division means subtract your exponents. Uh-oh, 3/4 minus a half, those aren't common denominators. So change your half into 2/4 so you can subtract. And you get s to the 1, 4. Hmm? All right, I'm actually just gonna kind of skip to the got it's for this, and we're gonna work on them together. Don't go ahead of me.
Oh.
I'm gonna start with B, okay? We just did basically the exact same problem, except it said X instead of Y. So for B, same base, division, what's the rule?
Multiply 3 over 1 to make it what?
What?
Can I just
Are we
tell you
doing
what it
B?
is?
No, just tell me what the rule is.
Subtract.
Subtract your exponents. So this would be
Change marker word.
D to the 7/2 minus, and now I know you wanted to say that part, so it's minus 3, but when we write it as a fraction, first we're gonna wanna write it as 3/1. Then we're gonna have to change it
What?
to get common denominators, he's right, times 2 times 2 is 6. So what we're really doing is D to the 7/2 minus 6/2, which is what?
D.
That one.
1 over 2.
Yeah,
Or 1
D to the 1/2.
Oh.
I'm in trouble.
Yep,
After you vote.
I called them.
No, they're probably after
He
J.
found me, no!
They're probably after
He
J.
found my face.
Yo, no.
No, I don't know what just happened, but it was funny apparently. All right, whoa, I made this one really big because it's so ugly. Okay, we're gonna make it pretty. We say take off the
No makeup for it.
What?
No makeup for it.
Wait, I got
Okay.
cancel
So Uriah pointed out something that's gonna make this really easy, really quick. He said his eyes immediately noticed x to the fourth in the numerator and x to the fourth in the denominator. Those are the same thing, so you can cancel them.
Yeah.
Right? It's just like if you have 2 over 2, or 10 over 10, or 9 over 9, or 6.3 over 6.3. They cancel.
What?
Why are my markers just... Oh my
Oh
god! No, it didn't.
It didn't go.
Only half of it went in, the other half just went somewhere else.
Okay.
There we go.
Okay.
Now it works.
So that was really simple. You know how else I can prove that they cancel out? Watch this. X to the fourth,
-4.
yep, x to the 4 minus 4 equals x to the 0.
Which, that means
Oh,
no
it's just
x.
like the elimination method.
Yes.
No.
Yeah.
X times x.
Sure.
X times x over.
All right. He's right. So now we have y to the -1 over y to the -5. What's the rule?
Subtract.
Subtract. So we have y to the -1 minus
Y to the 4th.
-5,
Which
Well,
is
that
plus
equals-
plus.
which is
Negative
kill the cockroach,
something.
change the sign, y to the 4th. Are we done?
No.
No, I haven't even finished. I just took care of my y's. What about my z's? Hey, this
I'll
one
get no
doesn't have an
z's.
It's
exponent.
1.
It does.
And then after that, you do that, and it becomes z equals.
No, not z equals.
I mean, z to the power of 9.
No.
Z to the power 8.
7.
6.
Oh,
Z has power 1, so you
Yeah, subtract and we get what? Yep, z to the power of 7. Much prettier now, right?
No.
Super ugly. That's nice and pretty.
No.
All right, next part. Just do that. I'm gonna skip the scientific notation for now. Okay. I'm gonna use this. I'm just making it big because these exponents are so tiny, okay? So when you
My bad.
when you have a quotient, which is a number being divided by another number, right? You have a quotient. And the whole quotient, put it away. Thanks. The whole thing, even though we can't actually say what the quotient is, we can't say what it is because it can't be simplified inside, right? It's as simple as it can get. The whole thing is being raised. You guys making some nice doodles over there, Lily? It's not really helping though, right? Awkward silence. You want me to move on? Shoulder shrug. It's time to take notes, okay? You know what you can write? This. Raise your hand if you already wrote this down. Raise your hand high if you already wrote this down. You can cross 2 problems off your homework for the weekend. Everybody else, write it down.
See, Miss Lake, look.
All right. If this is being raised to the 3rd power, doesn't that mean that z to the 2/3 over 5 is being multiplied times itself, z to the 2/3 over 5, and it's being multiplied times itself again, right? If this whole thing is being cubed, that means this times itself again. So doesn't that mean that the numerator is being cubed and the denominator is being cubed?
Yes. No.
No, I feel like this.
Yeah.
Yeah, because the whole thing's being used.
Because 5 times 5 times 5 is 5 cubed, and this times this times this is this cubed.
Yes.
So do you agree that if the whole quotient or the whole fraction is in parentheses raised to a power, that means both the numerator is being raised to the power and the denominator is being raised to the power. So again, we can kind of say that we're distributing this power to the numerator and to the denominator. Everything in the numerator and everything in the denominator, right? So we can simplify. Let's do the denominator first because it's super easy. 5 times 5 times 5, or 5 cubed in your calculator, would be what? 125. And our numerator, what is the rule for this?
Oh, you multiply the two exponents.
Yeah.
And then after that you get a number and like the
6 over 3.
Right,
Two.
and which reduces down to 2.
Oh.
Good?
Yeah.
Great. Let's do A. Try A on your own. It's, yeah.
Which one is this?
This one.
Okay.
Actually, we don't have time to try it on our own. We're doing it together. Sorry, I've got 3 minutes. If anybody packs up before I say, then you can stay. All right. So if everything is being cubed, that means the numerator is being cubed. Like I said, I didn't really need that parentheses, but it doesn't hurt. And the denominator is being cubed. I definitely need parentheses so I can separate my 3 and my 2 here. What's 4 cubed?
16.
What's x cubed? I'm sorry, 4 squared is 16. What's x cubed squared?
3 6.
X,
Like
X
6 is the 6.
X to the power of 6.
X to the power of
9.
6.
That's why I was saying 6. Like it's.
Oh.
Okay. X to the 6. Are we done?
No. Yes.
Yes.
Are we done? You actually have to think about it.
Yes.
Can it be simplified anymore?
No.
No, then we're done. Okay, I have one more thing to tell you. And this is fun. This is a fun one. Okay. It's gonna look weird. Actually, I'm gonna just write it because it looks weird. All right, so what if I have A over B
Yep.
to the negative 3 power?
That means A negative, wait, no, that'd be AB, no, 1 over AB.
Does this negative 3 belong to the numerator or the denominator?
Both.
Both.
And then I thought to make it
If they both got a bad attitude, then don't they both need to move?
Yes.
Yeah.
I thought you
Yes.
switch them.
One
but
over-
You do flippies!
Reciprocal.
So A goes to the denominator, B goes to the numerator, and they both have a positive attitude now with their power.
I'm so proud of you guys.
They have the power.
And that's it.
What if you just like why don't you just like put everything in the denominator, like the whole thing? 'Cause
You can't put this in the, you can't put this in the denominator, this has to go to the numerator. Because if this is being raised to the negative 3rd power, it's got a bad attitude, so it needs to leave and go upstairs.
well, like in the whole equation, like put it in a fraction, and then one over a b in parentheses negative 3 or 3. So 3.
Come up and show me. You guys can pack up. We come up and show me. Like trying to picture it, but I don't know. Yes, that actually is true. Yes, that is the same thing. But it's not the most simplified version of it because
Yeah.
Okay.